I'm not a particularly great threat actor or threat researcher, and yet I've found a million ways to do horrible things with AI agents. We have not seen that many AI agent related breaches and attacks yet. Why do you think that is?
As much as we are learning about it right now, live, so are the adversaries. If you're a nation state threat actor, you have a research group. You have people whose job it is to sit down and figure out how can I take advantage of this ecosystem. Meanwhile, your operations people are busy running your operations. They're something called PIRs, priority intelligence requirements. They're sitting down and they're saying, okay, I need to know what is happening in the Middle East. They have a backlog of items. As much as I want to joke about this, part of it might just be the JIRA ticket hasn't been answered by whoever the adversary researcher is. And if you're a cybercrime group, if you're somebody who's just trying to get monetary value out of whatever the capability that you're leveraging is, you don't have the same research and development as some of the more well-resourced threat actors do. You have to make sure whatever you put your effort into actually yields results. It could just be that as they're trying to learn, the adversaries are working their way up the capability ladder the same way that we're doing so on the defense side.
Let me actually just jump in and intro you. This is Keith Ramphal. He's done a bunch of incident response, vulnerability research, things like that. He's now doing cool research in formal validation of software, something like that I barely understand. And he's here to talk to us about a bunch of questions I have as they relate to this AI security space. You talked about different types of threat actors. You have these like nation state actors. You talk about them in a very organizational, structured way. And then you talk about these financial crime actors, and they're very separate. Can you help me understand the different types of threat actors that are participating at a very general level?
Sure. Any of the Intel people watching this, don't judge me too hard. I'm going to be a little abstract here. But basically, threat actors can be broken out into some different categories. Think of it as a pyramid of capability. At the top of the pyramid, you have your well-resourced advanced nation-state actors with their own integrated research and development arms that also have contracts with other research and development shops. They're the kind of people who can say, hey, there's a new capability. We're going to go just throw money at a team until they can spit out whatever it is that we need them to do. Because organizationally, their job is to collect intelligence or do effects on target or whatever that effect may be. If it's a disruption, if it's an understanding of what is going on inside of an adversary's environment, they have a job to do. They have tickets, they have bosses, they have mandatory PTO, they have all the things that go into an institution. They all have their employees badge in and badge out every day. Below that, you have less well-resourced, but still heavily backed by their national government type threat actors. You have folks who don't really have their integrated research and development arms. They don't have the ability to just open the money faucet and pour it on whatever the problem is. So they have to be judicious in how they spend their money, but they also will take advantage of third-party vendors. Think of them as not an enterprise scale entity, but something in the small to medium business kind of category. Below that, you then have your more advanced crimeware type gangs. They are there for the money. These organized crime groups are starting to see the value for them in operating in the ransomware and extortion and adversary operation space where they could not develop their own capabilities fully natively, but they have the ability to begin to do that sort of thing. They're very well resourced. They're very capable. They're not quite at the nation state level of capability because the legitimacy that a nation state brings to the table does tend to attract people. But we're starting to see advancements in these organized crime groups where there was actually a pretty interesting instance where some of the cartels were starting to fund students getting computer science degrees. Cartel scholarship for service, I guess. They will take advantage of whatever service lets them get as much money as possible for as little effort as possible. And below that, you just have your run-of-the-mill adversary actors who just spam attacks, and if they happen to get in, great. For them, it's all just about speed and ROI. You have more advanced crime groups that are very capable in some very domain-specific areas. They leverage that. They're not very advanced, but they just move at a speed in which an institution can't react, and then they just take the money and run.
Is crypto like a big area of that, or How does that weigh up against like the value of ransoming a company?
When you are an adversary trying to get a company to pay up, you are dealing with lawyers, you're dealing with negotiators, you're dealing with people. Companies will just say, nope, we're not paying the ransom no matter what the pain is, and they will just move on, right? You have now expended a degree of effort for no ROI. Crypto has an ROI. Wouldn't say that it's the biggest thing. It's just one of the things that tends to grab the most headlines.
Going also back, you mentioned that data actors are investing in researching these AI type threats, right?
Would be irresponsible of them not to be. If we're seeing it, then they have to be.
Okay. So are they reading my Twitter account?
I am not an Intel person in the traditional sense, which is why I ask for the tolerance of the Intel community when I'm talking about this, but they do collect information. They do send people to conferences. They do have research in trade journals, and they do read things to get an understanding of what is happening. Can I say specifically who is reading your Twitter? I can't give you that answer particularly, but I would not be surprised if people were not paying attention to the fact that we have effectively created a situation where you can argue your way into an exploit.
I kind of wonder to some extent whether they feel as embarrassed as I do when they find some of these exploits. So sometimes when I've proved like, haha, look at what you can do, I also am like, man, I'm glad I'm not a serious researcher because I'd be humiliated to publish what I'm about to publish, which is like, if you say the magic words, you.
To remember, they have their own version of KPIs. They have their own version of these sorts of things. And something to be very cognizant of is, yes, sometimes they're like, man, this is embarrassing. But if they can knock out whatever their objective is, and they can do it as cheaply as possible or as efficiently as possible, they're more than happy to do it. I used to have customers when I was doing incident response that were like, we're worried about nation state O days. And I'm like, you have server 2003 facing the web. Like,
Right.
the vulnerabilities on this are old enough to drink. The advanced adversaries are under no obligation to leverage their most advanced capabilities because there is a metagame to this from their perspective. If they leverage an advanced capability and they say, hey, we have a soft target, let's just throw this super cool capability at it. And then they call an incident response team, they call in Mandy, and they call in CrowdStrike. CrowdStrike, all these guys, they have some phenomenally capable people who are going to take that capability apart. And then once you do that, it becomes a degrading asset. The last thing that you want to do is take a super novel advanced capability, throw it at a soft target, and then when you have a hard target, you don't have that tool in your toolbox anymore because those guys are now very much on the lookout for whatever it was that you were doing. So if they have something easy and it is very straightforward for them to leverage it, and even better, if it's straightforward for them to leverage it in a non-attributable way, they will take full advantage of that every day of the week because they're like, oh man, I knocked out what I needed to do and there's no way it's going to come back to me. Great. I'm taking off and calling it a 3-day weekend.
I never thought about it in these terms, but it makes sense. If I look a year into the future, whether they're being exploited or not, I do feel AI gives us capabilities that will be new ways of attacking. So one of the things that some of these labs have been saying, Anthropic, closed source is safer because it allows us to control what other people have access to. And I've actually started to, unfortunately, have to agree with them. If someone right now handed me Opus 4.6 and I could run it locally and I could get rid of all the guardrails, like I could do the most damage. I could rip with that. Where do you stand on this argument, which from the lab seems very self-serving, but is to me increasingly kind of true?
For me, these models are non-deterministic. As a math guy, that already makes me a little bit twitchy. People have shown that they can bypass the guardrails. So I would rather have a full understanding of how the model works, everything about it. And people will say, you're not capable enough to understand it. Okay, that might be true, but let me make that decision. And this is a little bit of where my actual research comes in for formally understanding what these models are producing. Because 6 months ago, we were writing code by hand like cavemen, and now we're just arguing with the LLM until it generates roughly what we're hoping that it makes, right? Shake the linear algebra 8-ball and hope that what comes out is productive. If you don't understand what the models are doing, then you have to understand the output.
It's not about whether the markdown is safe. It's more about what the LLM chooses to do with it. The instructions to the AI are not safe or unsafe. And what happens that's safe or not safe is is what happens next. Is that
Right.
like a fair understanding of some of the stuff, kind of how you think about it?
That's how I think about it is yes, I care about the input insofar as the input allows me to try and understand what the intent was. My area of focus is explicitly on the output of what was generated, how can I prove what was generated, how can I prove what the capabilities are inside of that generated code base.
How much of this do you think is like solvable by LLMs themselves? Like, is it going to be AI solving AI, or is it going to be more conventional methods solving some of these AI problems?
Some of it will require LLMs. Part of the area, and I know all the math people are cringing because I'm about to say this, but even if we do automate away some of the trivial elements of this, we have a running joke. It's called proof generation via grad student. You just sit down and you have to just do a lot of this rote work by hand. And then once you've been able to do that work, you then confirm it and you're like, okay, it's proved. But if we can have an LLM automate it, like it's that same discussion of I have now lowered the barrier of validation. I have now lowered the cost.
I want to come back to a bit of your research stuff. I have one more question on pre-research. I think that developer machines in particular have gotten like orders of magnitude more exploitable in the last couple of months. Like if you go from having run JetBrains on your computer to write your code and push to GitHub to now you're running Claude Code on your computer and you're installing MCP servers and skills. If you're just an organization and you have developers, I view it as like your developer machines just became a lot easier to hack. How valuable of a target is a developer machine? Or versus servers, and I mean, what are these threat actors even looking at? Is it valuable to get into developer machines most places?
It depends on what their objectives are.
Okay.
Honestly, it does. If I'm working on a super sensitive project that I'm a developer on, and there's very few ways to get into this project other than my machine, you're going to find that that machine has now become a high priority target and they want the code. But developer machines have value just from an intellectual property standpoint.
How valuable are they from a lateral movement perspective? Most startups, of course, enormously, I'm sure, but I guess
It's
startups are not the traditional targets for most of these actors, right?
You'd be surprised, actually. It depends on the security posture of the organization, and our mutual colleague Spencer and Nathan McNulty and all these guys will tell you about the ways to do endpoint security, about the ways that things are locked down. Developer machines tend to have value because sometimes they are more loosely governed than the rest of the fleet inside the environment. And because developer credentials have the ability to deploy capabilities, they have the ability to build and burn things inside of cloud infrastructure. From a lateral movement perspective, from an identity guy standpoint, I would say that if you do proper isolation and segmentation, you should
They're
not worry about that. Now, for the 4 people that do proper isolation and segmentation, they're now just like, oh, okay, perfect. For developers, they have to have power because they need to have the capability to do things. We need our DevOps people to do DevOps things. We need everybody to do their job. We need to be able to say, how do we secure this? And that's where the problem is now is we don't know how to detect for some of these behaviors. Some of these AI capabilities hook right into the platform. And so you have to sit there and be like, okay, what is this thing doing? How do I trace it? Right. If I have a malicious process and all the malware people are now paying very close attention, if I have something, if I have malware running on a box, we have a general understanding of what that looks like. We know what is happening there. And for as much grief as I do give some EDR vendors, at the end of the day, they will look for whatever that thing is, and more often than not, they will find it, right? But for this new AI capability, how do I know my developer is doing developer stuff and not just having Claude Code yank my entire code base and throw it up on some random GitHub because he hit skip dangerous permissions? And hooked into, totally not Zach Corman's MCP server, and now all my data is hosted on some repo somewhere.
So we already talked about it for a bit. You're now doing research on what you refer to as formal verification stuff. I don't understand it fully. Can you maybe just like talk through a little bit of what you do now?
So formal verification, formal methods of software involve mathematically proving what it is that it's doing. Formal verification is good for proving what a system can do, but it's also good for proving what it can't do. Amazon uses formal verification very heavily all across their ecosystem. It is much more in depth in certain areas than just standard quality assurance. This bug might just be too complex for a tester to catch. Like Amazon found a 38-step bug in DynamoDB. They were able to say, like, under these circumstances, we can actually see that this system will do this activity. And then once they were able to do that, they were able to fix it. Formal methods are just one way of driving software understanding. They're just a mathematically verifiable way to say, I have proven that the software can do what I say that it does. For folks who are wondering why that's important, because in an era of non-deterministic code generation from machines that are doing natural language processing that are effectively black boxes to us, we have to be able to say, I understand what the capability of what I've just deployed is, right? How do I confirm that? Am I just going to continuously feed this thing from LLM to LLM to LLM and hope that I get? No, you want to generate a model of it. You want to be able to say, I have proven that this works. As much as we're joking about slop code, this is an answer to that. This is a solution to that problem where we can say, because I've been able to build this, I understand what it's doing. And it becomes a abstraction that I can parse easier than this overly formalized, nonsensical code base.
I was kind of sitting there going like, but the capabilities of the model is just the code, right? So at the end of the
Exactly.
day, the code is the capabilities, but I guess the point is that's quite abstract because like I'd have to read this sloppy
Yes,
spaghetti thing.
exactly. And the important thing there is that because folks will say, oh, well, I can read that code. Great. I can read that code too. All of us here can read that, but it's a massive time investment. Whereas understanding, parsing the model, being able to say that, it can allow you to enumerate what the capabilities of the code are. And part of the whole Langsec theoretic kind of component that I'm also working on is being able to find ways to remove a lot of these abstractions that create bugs that we all have major problems with. As an example, there is a platform where it cannot parse a null. The cloud platform cannot parse a null. Because the cloud platform can't parse a null, it will actually set that back to the beginning of the epoch and allow for tokens to be replayed. And this was found as just a routine security thing when we were testing some stuff here in the lab of they can't parse a null, they allow the tokens in. We are about to industrialize these kinds of problems at scale. Like we're about
Right.
to industrialize these kinds of problems in all of our code bases.
No, this makes a ton of sense. Cool. I think we could wrap up though. Is there anything else you wanted to talk about or cover?
I mean, I'm pretty good. Yeah, rock and roll.